This is question number 2 on the practice problems for test number 2. Factor each of the following expressions completely. If an expression cannot be factored, write prime or cannot be factored. Don't forget to look for the GCF. Part A, x squared minus 12x plus 35. So this is in our normal form where we can think about P and S. We want the product to be 35, the sum to be negative 12. If you haven't done this one yet, pause the video here and see if you can find the two numbers. So the two numbers in this case, what are we looking for? So 35 is 7 times 5, both negatives to get us that negative 12 in the middle. Part B, 3x squared minus 8x minus 3. We cannot do the product sum business here because there is a coefficient other than 1 sitting in the front. Product sum is only good when there's a 1 right there in the front. So we've got a different method we need to follow. You're welcome to do trial and error. You're welcome to do the box or rectangle method from the book. I'm going to do funky factoring, which involves first taking the leading 3 and jamming it into that constant term. X squared minus 8x minus, and we multiply the constant with that leading 3, gives me a minus 9. Now we can do the product sum business because it's a 1 sitting in the front. So pause the video here, see if you can do the product sum thing on the x squared minus 8x minus 9. So hopefully you came up with x minus 9 and x plus 1. But this is funky factoring, which means we're not done yet. So I'm going to copy those two things again, but I'm going to leave a little space in front of each of the x's. And that little space is to put the leading coefficient that ended up moving out of the way before. It goes back into both. And then our task is to divide each of these things by the greatest common factor that comes out of each one separately. So in the first parentheses, 3 goes into both. In the second parentheses, there isn't anything that goes into both other than 1. So I'll just put that there, but it's not going to change. And so our final answer is canceling or dividing 3 into both of these terms right here. First gives me x minus, and then 3 into 9 goes 3 times. And then 3x plus 1 divided by 1 is just 3x plus 1. Part C, 6t squared minus 1t minus 15. Again, we cannot do the product sum thing because of that 6. Product sum only works when there's a 1 in the front. So again, you're welcome to use the box method or trial and error. I will again do funky factoring. So we're going to take that 6 and peel it off and jam it in there into the minus 15. So let's see what's left. T squared minus 1t minus 90. Now you can do the product sum. So pause the video here, see if you can find two numbers whose product is negative 90 and whose sum is negative 1. Okay, hopefully we came up with t minus 10 and t plus 9. But it's funky factoring, so we're not done. Recopy those, but leave a little space. And then that 6 that we had peeled off before needs to come back in both places. And then separately divide by the greatest common factor in each of the parentheses. So in the first parentheses, I can pull out a 2. Second parentheses, I can pull out a 3 from both terms. And then whatever we get here is going to be our final answer. So 2 into both of the things upstairs. In the first parentheses is 3t minus 5. And the second parentheses, 3 into both terms, 2t plus 3. Moving on to part D. X to the 4th minus 16. Hopefully we recognize this as a difference of 2 squares. So in the first terms, we're trying to get a x to the 4th. That's got to be x squared and x squared. Second terms, I'm trying to get a 16, but it must be the same number from our difference of 2 squares formula. 1 plus, 1 minus. I'm going to copy this one, and I'm going to say that we can actually go further on the second set of parentheses. Because x squared minus 4 is itself a difference of 2 squares. x and x, trying to get a 4, 2 and 2, 1 plus, 1 minus. So there's our final answer. Part E, x cubed minus 6x squared. First thing to do is factor out the biggest power you can. So what can you take out of both of those terms? Not just x, but actually x squared comes out of both. We're left with x minus 6. And if we could go any further with x minus 6, then we would, but we can't, so we won't. That's our final answer. Part F, x to the 4th minus 25y squared. That reminds me quite a bit of part D. X to the 4th minus 16. Again, it's a perfect square. You see the 25. There's a y squared. That's a perfect square. So this is going to be another difference of 2 squares. So trying to build x to the 4th, we'll do that with an x squared and an x squared. In order to get 25y squared, that's got to be 5y and 5y, 1 plus, 1 minus. Now in the previous problem here, D, we were able to go further with the minus part, because sometimes that's also a difference of squares. So let's just look, does this thing have any potential as being a difference of 2 squares? Well, the x squared is good, it is a square, but 5y, neither the 5 nor the y is a perfect square, so we're done. But it's good to keep in mind that you do have to be looking on the lookout for that kind of thing when you're doing the difference of 2 squares. Moving on to part G, y cubed plus 12y squared plus 36y. Again, factor out the biggest GCF you can, the greatest common factor. I can take a y out of all of those terms. And now just for the thing in the parentheses, I'm ready to do my product sum business, and I can get away with it because it's a 1 in the front there. So looking for 2 numbers whose product is 36, whose sum is 12. Pause the video, see if you can find them. Hopefully you came up with plus 6 and plus 6. So that's our answer. If you want to write it more compactly, you can merge 2 y plus 6's together by writing it with a square. Part H, 3ab cubed minus 15a squared b squared plus 6b squared. Okay, again, can you factor anything out of all the terms? Well, you can factor a 3 out, so that's good. And can we factor out any a's? Well, I see an a here, I see an a squared there, but there's no a's in that term. So I can't factor any a's out, unfortunately. How about b's? Can we take any b's out? I see b's here, I see b's here, I see b's here. We can take b's out. So what's the most number of b's we can take out? Well, there's a b cubed, there's a b squared, there's another b squared. B squared is what we can take out of all of them. So what's left when I factor these things out? Well, let's see, the 3 is out, the b squared is out, so there's an a, and there's also a b. And then minus, so we've taken 3 out, so that becomes 5. The b squared's all outside, but we still have a squared there. And 3 comes out, so 6 shrinks down to 2. B squared all comes out, that's it. If the thing in the parentheses factored any further, you'd have to factor it, but it doesn't. It doesn't look like anything that we can factor, so that's our answer. Finally, part I, negative 6m cubed n plus 18m squared n minus 12mn. So we're going to try to factor out the GCF first. That's always a good first step. So I can take 6 out of all the terms. I can take out, let's see if we can take any m's out. You have m cubed, m squared, a single m. You're going to take out the smallest that you see, which is a single m. So we'll take m outside. And can we take any n's out? There's an n, there's an n, there's an n. They all have n. Let's take n out of all of them. And we'll write down what's left. 6 comes out, negative sign stays. One of the m's is outside, so there's an m squared left inside. In the next term, 18 comes down to 3. one of the m's comes out, so 1 is left inside. Negative 12 comes down to negative 2. And m and n are both outside, so that's it. Now, if we can factor the thing in the parentheses further, it's our obligation to do so. It doesn't look so great to me because there's a negative in front of the m squared. I always like my squared term to have a positive. Over here, this was a positive y squared, so I could do my normal product sum factoring. So how about we do this? Instead of taking out a 6mn, let's take out a negative 6mn. All that's going to do is change all the signs in the parentheses. M squared minus 3m plus 2. Pulling a negative sign outside changes all the signs inside. If you're not convinced that that's true, go ahead and take this thing right here and distribute it to all three terms and make sure you get exactly what we started with. So if we factor that out now, m squared looks good. It's just got a positive 1 coefficient. So I'm ready to do my product sum. So see if you can figure out the two numbers that you want. Pause the video and come back here. So hopefully you ended up with m minus 2 and m minus 1. And it feels like that's our final answer, except you got to make sure you don't lose the GCF. Negative 6mn is there. It doesn't disappear. It's part of the answer as well.